Okay, so we've got, we're still on question 2. We've moved on to C. And I just did an expression, so it's asking for the differential of the log x squared plus 5x. So that's that part. So just getting a few things sorted out here. Alright, so now look, I mean the thing is it says to operate with the log laws. Strictly speaking, that's not necessary. Okay, so that's that one. Okay, so alright, so we can just have a look at that. Alright, sorry, I'm just checking things as I go, just to make sure. Look, it says simplify the log laws from D onwards, so you'll notice that from D onwards, okay? Just for that part. Alright, so what we can do here. Now, this is absolutely not necessary on one level, but anyway, I did an expression now, so I'm assigning y and going to do that. Look, I think sometimes some things are nice to do to get you into practice, aren't they? So let u equal x squared plus 5x, and u the x is going to be whatever's written there. So y is equal to the ln of u, so dy du. Okay, so we've got 2x doing the calculus, there it goes, and 1 over u. So y dash is going to be dy dx. So we can do the chain. I'll let you put those bits in. So it'll be 1 over u is x squared. So we can put the 2x, so you can see they're a product. I was just going to write this as a product, just to let you see the chain rule in action. Okay, that's how it actually looks, but obviously what you'll do is you put them together. Okay, x squared plus 5x, and then again I would suggest that there's no simplification there. Alright, so having said that, let's move on to the next one. So we're at D here now, so D is this one, so D is, now I just did an equation, so I'll use an expression, d dx, the ln of the square root of 3x plus 4. Okay, so what we're looking to do is maybe some pre-work. Okay, some pre-work. If I do d dx, the ln of 3x plus 4 to the power of half. Okay, maybe we can take the half out the front, because that's a log law, isn't it? So we can do d dx 1/2 the ln of 3x plus 4. Okay, and then we can think about doing our actual differential. So the half is needed just for this part. So we'll have let u equal, this will be the same regardless of the form that you're working. So those forms won't change. So du dx will be equal to 3. That's the calculus out of the way. This one here now needs to make sense. So we'll do d du a half ln u. So that means the ln of u will be 1 on u. So the half is already there. So we'll bring the result of this down here as 1 over 2u, and that's the chain. That's the chain that we're putting together. So we've got the chain will be the d dx of ln the square root of 3x plus 4 will be equal to the chain 3 over 2 times u, which was 3x plus 4. So that's our final result. Okay, so the half, whether it's absorbed in that quotient or sits out the front here as a half, doesn't matter. Okay, so either way, you can check those. You can do it as a y equals, or you can do it as an expression. Okay, either way is helpful. All right. Now, why are we doing the log laws? Because it just means that if you had to do it as, if you didn't use your log laws, it would make it just a little bit more complicated. Okay, because what we've got here is an example where we can show maybe both types. So if I make this y equals the ln of 3x plus 9 to the power 4, if I don't invoke a log law here, it's going to be more complicated. Okay? If I don't invoke a log law, we'll get the same result, but I'm just going to show you. We will get the same result, but the log law pre-work would allow us to move the 4. So y would be 4 times the ln of 3x plus 9. So that means we would let u equal 3x plus 9. That means that the u dx would be equal to 3. Over here, we would write y in terms of u for the ln of u, and so dy du, doing the calculus now, would be 4 times 1 over u, because ln of u is 1 over u, which is equal to 4 on u. Okay, so putting the chains together means putting these terms together. So 3 4s are 12. dy dx, putting all of your chains together, I'll let you do that, is 3, so 4 on u is 3x plus 5 times 3, and that becomes 12 over 3x plus 9. I said 5, but it's 9. 3x plus 9. And that's your final kind of result. Okay, so that's good. That's your final there. Okay, so what would happen if we had to do it up here? We would have to let, now I'm going to change I'm going to let m. Now I would have to let m because in a way what you're not seeing is the ln is taking into account a whole lot. So m would be equal to 3x plus 9 all to the power 4. But now we've still got a problem here because that's a chain still. So we would have to let n equal 3x plus 9. So we have a little bit of writing to do. So y would become the ln of m. Okay, m is that, so that's fine. N, now n, let n equal 3x, so m would become n to the power 4. So then you've got 3 equations, 3 chains. So we would have to do dy dm dm dn and dn dx. So as an expression, this method would be quite a bit complicated. So that would be the ln of m, do the calculus, it's very straightforward. 4n3, and this is just 3. Okay, so what we get is the chain. We're putting all of these together as our chain. It's a triple chain, isn't it? It's a triple chain. It's dy dx is having dy dm dm dn and dn dx. Okay, dm dx. So we put all those together and we'll get 1 on m. I'll just leave them in their natives at the moment, times 4n3, just so you can see the chaining going on. Okay, so there's times. So then we can do 4 3s are 12n cubed, 12 something cubed, and the n was 3x plus 9. Okay, and m was n to the power 4. So it's 3x plus 9 to the power 4. Now, that requires an index perception. We can clearly see that that's going to cancel. And so what we're going to end up with is that will be gone. So we're going to end up with the same answer, but we needed to do the index perception. Okay, so dy dx is this one. So it's a little bit more involved if you don't do the log law. So the idea of the log law, invoking the log law, simplifies how many times you have to do the chain rule. So in this case, doing the chain rule twice is all that was needed because we invoked the power moving out the front. Here, by leaving it, we had to not only select the correct input, the correct substitution, we had to do 3 of them, and we had to assemble the chain that way. So either way is doable, but I think I've won the idea that, choosing to use the log laws makes the whole thing a bit more simplified. All right, so that was E, wasn't it? That was 2E. All right, same kind of thing here for F. If we don't recognize that we are invoking the log law, so it fits into pre-work, we're going to end up doing a differentiation on a quotient, which would require the quotient rule. But what this allows us to do is to recognize that the ln of the numerator can be subtracted from the ln of the denominator. So then they can be treated as separate entities. So that simplifies the problem quite a bit in terms of doing chain rules, because the chain of that's 2 and that's 3. So we're going to get 2 and 3 over the ln of u. So we're going to get 2 and 3 over the ln of u. I verbalized that in my head, but I'm going to continue it for you. Okay. So if we ddx the expression, ddx the ln of 2x plus 1 minus the ln, so we're just going to treat them as individual expressions. Unusually, we're going to have to do 2 chain rules. So let m equal 2x plus 1. Over here, let n equal 3x minus 4. So we've got dm dx and dn dx. And then over here, instead of having what we've got here is a ddm, so we can separate them. So we're going to have a ddm of the ln of m equals, and we're going to have a ddn of the ln minus ln of n. Okay, so just having to pull that together to use them individually. So the ddx will finally come down here, but before we do that, we can do the actual thing. So the ln of m is 1 over m. So that changed together with this one, which is 2. So it'll be 2 over m. This one, which is what I was saying before, this one here is 1 over n, and this one here is 3. So our final chain will be putting these together, 2 over m, which itself was 2x plus 1, and we can't simplify that, minus, putting these chains together, 3 over 3x minus 4. Okay, and that's our final result. So the ddx of the ln of the quotient is there. So that's our final expression. So whether you do it by equations or by expressions, so I'd challenge you to get the same answer using the equations, doing them alternately the way that I am. All right, I'll come back for G and H in a minute, but that'll do for now. Back soon.